Hi everyone, this is Umakan. Welcome all of you to my channel. So here I am with a new video. This video is all about the BRC interview experience of my friend Bishal Basak, who is working as a scientist in BRC Mumbai. So in this year of 2021, he is elected as a scientific officer in BRC. So here we will discuss the details of his interview experience and how are the question and how he has tackled the question inside the hall. So he has sent all the question to me, and here I am with all the questions. So here first question was find the acceleration and the tension in a uttered machine without deriving them step by step. So just use the concept and write the mentioned quantity. So the question was from the uttered machine, that is basic classical mechanics. Then the question was, if we solve the uttered machine by Lagrangian method, then we solve it by Newtonian method. So what information are missed in Lagrangian method but can be concluded easily from the Newton mechanics? So this is the basic beats between Lagrangian mechanics and Newtonian mechanics. So whenever you are talking about Lagrangian, so you have to take the kinetic energy and potential energy in the consideration. But in Newtonian mechanics, so you have to use the F equal to ma, that is d square x by dt square. So basically you have to solve this problem in both the way and have to conclude the difference between the Newtonian mechanics and Lagrangian that is used to solve such problem. Okay, so this is the question from classical mechanics. So then there is a question, as you solve the above two just by finding oscillation in the above problem using Newton mechanics. So what is the core concept in the above method using the using that solve the infinite uttered machine? So देखो, so in that question you have to find the oscillation, because whenever you have a uttered machine, so you have to use the both the Lagrangian mechanics as well as Newton mechanics to find out the oscillation. Then they ask to solve the infinite uttered machine. So you have solved for one system, then you have to solve for infinite uttered machine. So such question is asked, see, because people will give you a simple question, then try to extend it to as much or deeper can be possible. Okay, and they will check your capability to think deeper. Okay, so such situation is there. So never think they will give you a certain problem, and if you answer them, then they will close the question there. No, the situation will be not like that. They will they will try to uh, uh, take you deeper and deeper, how much is possible, and up to which you can think. Okay, so be prepared like that. And whenever you are solving something, so thinking about the side question, branch question, and the deep questions, what can be possible from that concept. So move to the next. Then the question was from solid state physics. So what are the symmetric element of a square? So if you have a square, then what kind of symmetry can be possible in that square? This is a very general question. Then can you use Braggs law for neutron? So if you have a neutron as a probe, then can you use the Braggs law, that is n lambda equal to 2d sine theta? So this is the question. Then this is very important question. So you have to check the wavelength first of all with respect to energy. So for what energy you have what range of wavelength, and corresponding wavelength should be equal to the interplanar spacing of the lattice, that is crystal. Okay, so modify Braggs law if you know the energy of photon and the neutron, then convert it. So as I mentioned, you have energy, then you have to find its corresponding wavelength. If this wavelength is nearly equal to the interplanar spacing of the solid, then you can use Newton as a probe for the diffraction phenomena. Okay, so this is very important and a crucial information they have given. So then they asked to prove the 2d sin theta equal to n lambda. This is very basic, one can easily find out. So then this is 2 kg equal to g square, that is Law condition. So and how to show, and have to show the equivalence between these two relation, that is 2d sin theta equal to n lambda and 2 kg equal to g square, where where this two relation is equivalent. Okay, so practice it carefully. This is one of the basic and important relationship. So then they jump into the nuclear physics and have asked about the beta decay. So what kind of beta decay have there, like beta plus beta minus. Then have to draw the necessary spectrum for the both the beta decay, that is beta plus spectrum and beta minus spectrum. So then how X-ray are produced? This is once again come to the solid state, that is how X-ray is produced. That is, you have to say about the high energetic electron fall on the heavy target material molybdenum copper. Then how X-ray generated, there K alpha line and K beta line. The thing is like that. I have already mentioned in my some of my previous video. That is how X-ray is produced. So you can check. So then the give the region of production of continuous line in spectrum in X-ray. This is very important. So whenever you have a X-ray spectrum like this, so you have a spectrum like this, so you have to know this continuous spectrum about, and how K alpha K beta line is produced. So this is all about the X-ray. So I will suggest you to please go through BD Quality. This is one of the important and very informative book. So basic of X-ray diffraction is deeply explained there, so one can understand everything about the X-ray diffraction from BD Quality. Okay, so then draw the diagram of electron that is interact with the atom uh, via Bremsstrahlung method. This is one kind of very a new thing. Actually, I don't have any idea about this method, but such question can be asked. If you don't have an idea, then you can please tell. It's very new for me, so I have no idea about this. So such thing is going inside that hall. Then move to the next part, that is they asked about what is the difference between the beta plus and beta minus spectrum. This is very basic question. So you have to know the basic difference between beta plus and beta minus spectrum. Why there is space different? Okay, so this is a question. Then they have asked to write the Dirac equation. This is very famous equation in physics. Then gave the Feynman diagram of beta decay. So Feynman diagram of beta decay they have asked to draw. Then term theory of Fermi theory of beta decay was asked. Then Feynman diagram of basic beta decay was correctly. Then what is the region for that? Then they asked about the energy uncertainty relation. So as you know, the energy uncertainty relation, that is del E into del T equal to h cot. So they have asked about this energy uncertainty relationship. Then what do you mean by uncertainty in energy? Draw and show the uncertainty in energy in two level system. So these are the basic fundamental question from the energy uncertainty principle they have asked. So then what is the mean by uncertainty energy? So I have already mentioned this question. So this is I already mentioned. Then one of the mathematical question they have asked that about iota to the power iota. Okay, so iota to the power iota will be real or imaginary? So it will be real or imaginary. So this is a very fundamental question, so try to find out it. So then about except this 19 question, so as Vishal mentioned, only 19 question asked to hear him, but while discussing there was a very lot of small questions are there. So like sometimes you will try to explain something, but they will ask very little bit question related to that concept, they can ask. Okay, so if you count, there will several number of questions can be asked inside the interview hall. So basically 19 major question was asked directly to him. Okay, so beside that they also have asked about what is Gaussian, then what is Lorentzian, then draw them the Gaussian function and the Lorentzian function, then write their form. So basic form should be memorized about the Lorentzian function and Gaussian function. So Gaussian is generally people know, then you should know about Lorentzian function, because basically we don't use Lorentzian function mostly in physics. We basically use Gaussian. So compare them. So what to get them? This is a very basic question between Gaussian and Lorentzian function. Okay. So thank you so much. This is all about the BRC interview experience of my friend Bishal. So he's now working in BRC as a scientific officer. So hope you got the details question of Bishal that I asked to him. So hope you enjoyed the video. Thank you so much for supporting my YouTube channel. And if you like this video, then please like my video, share my video, and subscribe my channel. Thank you so much.